Hey guys, Dean Chase here with another geometry lesson for you. Hope everybody's doing good. Let's go ahead and get this thing started with a word of prayer. Dear Heavenly Father, I want to thank you for this day. I want to thank you for all you do. I want to thank you for the opportunity to teach. Please bless my students. Help us all have a good day. Amen. Alright guys, so today we're going to be covering lesson 3.2, and we're going to learn how to use parallel lines and transversals. Okay, it's page 154 if you're following out of the book I'm teaching out of. Real quick, today's lesson, everybody I've talked to is always like, man, is that really it? Is that easy? And it is that easy. So we're just taking what we learned yesterday and applying it to parallel lines. So let's jump in. So the first thing we're going to cover is corresponding angles postulate. Yesterday you learned what corresponding angles are, and today we're going to learn a postulate that applies to corresponding angles. Postulate 15, corresponding angles postulate. If two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. So, real quick, angle 2 is congruent to angle 6. Also, these purple angles would be corresponding angles, right? And these green angles would be corresponding angles. And these blue angles are corresponding angles. So all those angles would be congruent to their own color. Yeah, let's keep going. So example 1, the measure of 3 of the numbered angles is 55 degrees. Identify the angles. Explain your reasoning. So they give us one angle is 55 degrees, and they want us to tell what other 3 angles are equal to 55 degrees. So right off the back, we could say that angle 6 is 55 degrees also by what we just learned. Angle 6 by the corresponding, I'm going to just draw an angle symbol. Angles postulate. Okay? I hope that one made sense. We can also say that 3 is also 55 degrees because 3 and this angle are vertical angles. Angle 3 by the vert angles congruence, I think theorem. Let me double check that real quick. Yep, theorem. Good. Last, we could also say that 7 is 55 degrees, and we have 2 options because we said 3 by the vertical angles theorem is 55 degrees. So we could say 7 is 55 degrees because 3 and 7 are corresponding angles. But we also know that 6 is 55 degrees. So we could also use the vert angles congruence theorem. So I'm not even going to write it down. I'm going to leave it up to you what you want to write down. Okay? Because it could be either vertical angles congruence theorem or the corresponding angles postulate. Both of those would work because that's what geometry is all about. It's about building an order to prove things. So we proved 3 and we proved 6, so we could prove 7 in any of those ways and it still would have been an acceptable answer. Let's go ahead and move on. So the other 3 theorems we're going to learn today are the alternate interior angles theorem, which states if 2 parallel lines are cut by a transversal, then the pair of alternate interior angles are congruent. So you have these 2 parallel lines, P and Q. We know the parallel because of these little symbols right here. And because of that, we know that they're cut by this transversal, that 4 and 5 are congruent by the alternate interior angles theorem. Also, both of these blue angles would be congruent by the alternate interior angles theorem. So, theorem 3.2, alternate exterior angles theorem. If 2 parallel lines are cut by a transversal, so 2 parallel lines, P and Q, the symbol, are cut by a transversal, then the pair of alternate exterior angles are congruent. So 1 and 8 are congruent, and these green angles would be congruent. Okay, theorem 3.3, consecutive interior angles theorem. If 2 parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Okay, remember, so that one's different than all the other ones we learned because so far everything has been congruent, but our last one, the consecutive interior angles theorem, says they're supplementary. Supplementary means that the angles add up to equal 180 degrees. So 5 and 3 add up to equal 180, and also these two red angles would also add up to equal 180. So let's keep going. Here they want us to find the value of x. This seems very unoriginal because we're going to use the corresponding angles postulate again, because 135 and this angle are corresponding angles. So since we know they're corresponding angles, we know that they are equal to each other. So let's just go ahead and write our equation out. 135 equals x minus 30, okay? And to solve this, pretty simple math. We just add 30 to each side of the equation. These 30s cancel out. 165 equals x. And guys, we're done. Not bad at all. So let's just go ahead and keep carrying on. So here they want us to prove that if two parallel lines are cut by a transversal, then the exterior angles are angles on the same side of the transversal are supplementary. So we're given that P is parallel to Q. P is parallel to Q. I'll draw little arrows here, even though they won't be pretty. They're there. Okay? So the first thing we're going to do when we're writing our proof is we're going to go ahead and write our givens. So P is parallel to Q, and that is given. Okay. The next thing we need to do is try and find some sort of relationship that we could build off of in this graph. So right here, angle 1 and angle 3 lie on the same line, and they're adjacent to each other. So we know that they're actually a linear pair. So angle 1, the measure of angle 1 plus the measure of angle 3 equals 180 degrees. And we know that because of the linear pair postulate. Okay. So with that, we're actually going to say we're gonna okay, sorry. With that, let's move on. Now we have angle 3 right here and angle 2, and those are a special kind of pair. What are they? They're corresponding angles because they lie on the same side of the parallel lines and on the same side of the transversal. So corresponding angles. And we know that corresponding angles are congruent. And the reason we know that is the corresponding angles postulate. If we know that angle 2 and angle 3 are congruent, we know that the measure of angle 2 and the measure of angle 3 are also equal. It may seem really redundant, but it's logical, and that's why we do it. And the reason we know they're equal is the definition of congruent angles. Okay, now we know that angle 2 and angle 3 are congruent. We know that the measure of angle 1 plus the measure of angle 3 equal 180 degrees. So we can actually say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And what we did here is we substituted in the 2 for the 3 in this equation, okay? So we use substitution. Last, if we know that the measure of angle 1 plus the measure of angle 2 equal 180 degrees, we can state that they are supplementary to each other. And that is the definition of supplementary angles. Hi guys, that was the proof. I'm really hoping that as time is going on that our proofs are becoming easier and easier, and maybe you're beginning to have the logical processing of solving these proofs. Let's just carry on. Last example, and then we're out of here. This is crazy quick. So the figure shows a balanced scale. If the measure of angle 1 is 70 degrees, what is the measure of angle 2, and how do you know? Okay, so this is going to take a little bit of extra imagination, but you have to imagine, since these two lines, my wife's calling me, since these two lines are going to be parallel, because they have to hold that straight, otherwise everything would fall off the top of the scale. Let's go ahead and draw two parallel lines. Okay? And then it's cut by this transversal. Now, if we look at these two angles, what do we know about angle 1 and angle 2? They are consecutive interior angles, and we know that consecutive interior angles add up to equal 180 degrees, that they're supplementary. So angle 1 plus measure of angle 1 plus the measure of angle 2 equals 180. So we know that the measure of angle 1 is 70 plus the measure of angle 2 equals 180. Okay? We could subtract 70 from each side. And then the measure of angle 2 equals 110 degrees. And that's it, guys. Pretty simple lesson. I hope you guys are all having a good day. I'll catch you in the next one. See ya!